Good afternoon. At the outset, I would like to thank Mr. Sebastian Dufran for inviting me to this session at the Belgian Road Congress. Big data deployment or utilization offers valuable prospects for identifying the issues with the road transport industry. My talk is based on one of our European projects where big data from different sources were analyzed and devised a research and policy roadmap for utilization of big data in transport field that you required for making better decisions and to reduce your road transport project cost. It provides incremental steps necessary towards data openness and sharing to manage assets efficiently and more sustainable manner. You are familiar with asset management. Asset management is largely a data-driven process, as one of the key elements of asset management is using data to support decisions. However, the databases representing inventory and historical records of road bridge and roadside assets collected using video logging, automated pavement distress survey, regular inspections, structural health monitoring, as well as other methods can rapidly explode. This data is key to preserving physical assets in a state of good repair and addressing safety issues. But tasks such as capture, curation, storage, search, sharing, and analysis are challenging as our capability to collect data grows. Ideally, good data will be comparable, transferable, interoperable, automated, and visual. Uh, this is, or in this respect, big data helps to achieve more and more proactively road transport data assets to support the management of our physical assets. In addition to that, big data analytics ensures efficient asset management and offers more reliable and sustainable networks. Information resources such as GSP units, acoustics, and visual sensors, field tablets, and maintenance logs offer rich analytics to influence both human and automated decision making. So what is big data here? Big data promises to provide insights into behavior, performance, and interactions. At the same time, the nature of the data sets possess challenges, as not all data have the same quality. The explosion of data in the digital age has compounded the complexity of technology transformation across each of these different 5 areas: the complex scale of operations, technology issues, organizational silos, skill gaps, and highly depreciated infrastructure landscapes. Remarkably, big data offers answers in many of these challenges or challenging areas. However, some institutional and governmental level challenges using big data are too conversant. For instance, the need to break down silos and control tower approach to security and privacy, and a huge variety of data. While big data is ubiquitous, we can say ubiquitous terminology today, there is still no consensus among scholars and professionals on the definition of big data. So we defined big data as given on this slide, uh, with a focus on road transport sector. Big data can mean one of the four things. The first one is volume. Volume is the most popular and obvious characteristics of big data, as the first word of big is indicating these characteristics. The massive volume of data collected from millions of vehicles, social data, sensor data, etc. That's the volume of data. Then variety. That means differences within the industry standards, sampling rates, and data types such as video, uh, different XML pictures, uh, text files, images, videos, etc., etc. The third one is velocity. It is a speed or the high arrival rate data. For instance, sensors data, weather data, GPS data, that is global positioning system, data coming from the global positioning system, uh, social media messages, and the data generated from the vehicle onboard devices, etc. And the fourth one is veracity. This is very important. The veracity is the potential for missing or enormous amount of data due to environmental conditions, unreliable data sources, equipment failures, and malicious intents. So the focus on big data for the transport sector comes from two distinct trends. First, in the past decade, digital technology has permitted many facets, ranging from communications to economic activity, trades, and transportation. Digitalized activities have created a massive amount of records, whether as a functional objects or as a byproduct, that in some cases have been stored as electronic data. Many have identified this data as potential source of useful information. So it is reasonable to ask the question, with all the data that I have access to, what can I do with it? In short, it is a potential solution seeking a problem. The problem we have identified, and we will focus on is in transport domain. The second trend is the realization that existing methods of creating information for the purposes of planning, control, and evaluation, these are costly. For example, expensive to carry out, taking a long time, and not easily scalable. This very constraint in terms of limited coverage, especially geographically, then sample size, and temporally. On a small scale, these challenges are manageable, but on the large scale, for instance, in urban transport or urban transport planning, the lack of good, timely information can cause long-term negative effects, which are difficult to mitigate. These effects have been identified as both failures of public policy and market failures, leading to economic losses and undesirable social and environmental outcomes. What we want to ensure through sustainable transport activity by means of good planning, control, and evaluation is that the benefit of transport are boosted or at least maintained, while the limitations are reduced and eliminated. While such outcomes cannot be guaranteed, techniques and approaches to achieve them through big data driven analytics hold for potential for improving them. So a few weeks ago, the European Commission recommended new rules on who can use and access data generated in EU across all economic sectors. The Data Act will ensure that industrial data is shared, stored, processed in full respect of European rules. With the Data Governance or Data Governance Act agreed today, they are defining a common approach to data sharing. Europe is doing this by building trust. Trust is very important. Putting the individuals and the businesses who generate data in the driving seat so that remain in control of the data they create. And in short, an open yet sovereign data single market for data. Now, I would like to present some legal issues identified and examined in our project. These issues are relevant to the production of, access to, linking of, and reuse of big data in transport. Privacy and data protection, that is one issue we have identified. Some concepts, principles, and obligations under data protection law appear to be problematic for the uptake of big data. Then another issue is cybersecurity. The requirement to put in place security measurements security measures in security measures is imposed in various legislations at European and national level, including key instruments like the GDPR directive. Then breach-related obligations. The various actors of the data value chain need to implement measures, procedures, and policies to abide by the strict notification requirements and be prepared to provide the necessary information to authorities within the imposed deadlines. Such requirements will also need to adequately reflected in the various contracts between the stakeholders involved in this chain, the data value chain, in order to adequately address any incident that may occur. Anonymization and is also another technique generally provide fertile ground for opportunities with respect to big data applications. And likewise, all other issues important for moving forward to encourage the production of, access to, linking of, and reuse of big data. Similarly, further, we have also explored and scrutinized various societal and ethical issues. For instance, trust is one important issue. Although research in the trust is already become relatively mature, the huge amount and diversity of data and data sources provides a lot of new opportunity, but at the same time poses many challenges for online trust. Surveillance, considering the role of government agencies and their increasing request of information to the private sector for public security purposes, it appears necessary to adopt specific rules to regulate the information flow and to define the rights over data and to ensure adequate enforcement. Privacy, including transparency, consent, and control. See, the advent of GDPR has had a considerable impact in the domain of privacy, transparency, consent, and control. This strengthened the legal framework and is likely to respond to the several ethical issues and thus improve and the user's trust in the use of personal data in big data context. There are other issues like free will, the personal data ownership, and discrimination. Discrimination, especially using big data analytics to improve business processes or provide personalized services, may lead to discrimination of certain groups of people. Also, the digital divide, that is the social differences in across to technology, in access to technology or skills to use it, may lead to data driven discrimination. And another important issue is environmental issue. That is, there is a trade-off or rebound effects from the use of big data in transport, which limits the effects of big data exploitation, and it creates unintended consequences. So on this diagram, we are seeing different issues relevant to the production of, access to, linking of, and reuse of big data. We have considered here four different aspects, like technological aspects, policy, legal aspects, in economic and political aspects, and ethical and social aspects. We have extracted a total of 129 barriers related to these 31 issues presented on this slide. Further, we have revealed a total of 114 opportunities connected with 32 issues shown on this figure. We have conducted a detailed horizontal analysis or a trend analysis by considering results of various European projects as well as other international initiatives in the road transport field. We analyzed relevant initiatives and policies in Europe and 15 other countries other than Europe, other international countries, and link them to a research dimension to understand the disjoint relationship between new information and the strategic impacts on transport organizations, especially on the road transport organizations. Also, we tied the research challenges described in the roadmap of the Strategic Transport Research and Innovation Agenda, STRIA. And ultimately, here you will see the roadmap for leveraging big data to manage transport operations in Europe. So this is our final product. This roadmap includes a set of actions from the research and policy point of view that governments, businesses, and industries in Europe should implement in order to improve, to effectively take advantage of big data solutions with the aim of providing added value for society in transport sector. This roadmap is divided into two parts, namely a research roadmap that focusing on identifying the research priorities at stake, and the policy roadmap providing a set of recommendations to build a policy framework which will ensure that the European transport sector can make the most out of the data transition. In total, roadmap contains 11 research actions and 13 policy actions, which are spread over 11 themes. These actions are designed to improve the data economy in the transport sector and provide a source of inspiration for further research in the area. This roadmap ends with a suggestion for the implementation of these different actions. And both research and policy roadmap present different perspectives which, when combined, outline a clear set of actions for European policy and research from political, economic, social, technological, legal, and ethical perspectives. On this slide, you will see the total 24 action scores on three common assessment criteria, namely urgency, impact, and feasibility of an action. In this context, urgency relates to the speed with which the action has to be implemented and indicates the time frame within which the action should be carried out. Impact signifies the effectiveness of the action and the usefulness of action in achieving a larger objective. And feasibility encompasses the political, financial, ethical, legal, and technical practicalities of implementing the action. So we do realize that rating is a simplification of the complexity of actions. The rating should therefore be seen as a recommendation to prioritize different actions and as a source of inspiration for further research in this area. So thank you for your attention. Thanks also to the conference organizers for giving me opportunity to speak and for letting me share my ideas with you today. Thank you.